All right, so now for the second part here of this review, this is for the honors class. The first question says, find the real solution of the equation, round your answer to the nearest hundredth. So remember, if we're thinking about the number 100, that means two decimal places, so two places after the decimal. Now, when we're solving something like this, yes, there's a power of 4. We're going to need to get rid of that power. But before I can bring in radicals, I do need to get all these other numbers out of the way. So we're going to subtract the 3 from both sides, leaving me with 5x minus 4 to the power of 4 is equal to 80. Now, we're still not ready to bring in radicals because of this 5. So the only way to get rid of that 5 is to divide everybody by 5. So then we end up with x minus 4 to the power of 4 is equal to 16 when I divide the 80 by 5. Now we're ready for a power, or sorry, for a radical. Just remember that the only way to get rid of a power of 4 is to bring in a radical with a matching index. They have to match for this to work. Now, because I am getting rid of a power that's even, when I write my x minus 4, I do need to write in plus or minus because we have two possible answers for this one. And then it's going to be the fourth root of 16. And the fourth root of 16 here. And so the fourth root of 16, once again, is just 2. And because we have a plus or minus, we know we're going to have two possible answers. So x minus 4 is equal to 2, and x minus 4 is equal to negative 2. Once we add the 4 to both sides, we end up with x is equal to 6 as our first solution. And over here, when we add the 4 to both sides, we end up with an answer of x is equal to 2. So there are two answers. Now it said round off to the nearest hundredth. That's probably just in case this right here doesn't work out to be a nice little whole number like this one did. All right. So number 38. In number 38, they said we have the function f, which is represented by 2x squared minus 6. And remember, that's going to be the first function we work with. And then they said g of x. Well, g of x is our second function that's inside. So when they want me to work with something like this, remember, I'm working with f first. So in working with f, we write the first function, f. So here it is. I see an x, I'm going to leave it blank. I write the 2. I see an x, so I leave it blank. Squared, I give it a power 2, minus 6. So what I need to bring in is that g function. The g function is what's going to go inside. And so when I work this part out here, throw in that g of x. G of x is x minus 4. So now keep in mind, there is a 2 out here, still patiently waiting, and that minus 6 is still waiting out there. What I need to take care of is that power of 2 here first. But we have our binomial expansion rules that will do this, that'll let us do this a little faster. So x squared is x squared. X times negative 4 is negative 4x, but then I doubled it, so it's negative 8x. And then negative 4 squared is positive 16. We're not ready for that subtraction yet. If you notice, there's still that distribution of that 2 that's out here in front. So I do need to distribute that 2 first. Then I'll be able to work with that negative 6. So we end up with 2x squared minus 16x, and 2 times 16 is 32. And we're going to subtract our x from there, of course. So at the end of it all, 2x squared minus 16x, 32 take away 6 is just 26. And that's as far as we go because they wanted me to create a new equation called f of g of x. So that would be our solution. Now, number 39. For number 39, it says, find the value of x that makes the equation true. So we're solving for x. It is stuck inside of a radical. The only way to get rid of a radical is to use powers, but we're not quite ready for that. We need to remove every other number surrounding that radical. So it's a cube root of x minus 6 all over 4. And once we subtract our 3 minus 2, which is 1, it's now time for us to get rid of that 4. Now, in order for us to get rid of that 4, because it's a division by 4, then I'm going to multiply both sides by that 4. So that's going to cancel the 4s out. The cube root of x minus 6 there we go, is equal to 4. And now we know that the only thing that gets rid of a radical is a power, but the only power it can bring in has to be one that matches. So we get in that power of 3. So x minus 6 is equal to, and then of course 4 to the power of 3. It's one of the ones that we asked that you know to save you a little bit of time, is 64. And last step, all we have to do now is add the 6 to both sides. And just like that, x is equal to 70. Now, technically, we should be checking our answer, of course. And the reason we need to check is we have to watch out for any extraneous solutions. But we only have one answer that usually end up working out. But we can do a quick check. And again, we can let Desmos do all of this work for us. And we just plug in that 70 minus 6 all over 4 plus 2. And the question is, will it equal a 3? So let's see what this thing looks like on Desmos here. All right, so we have our fraction. We're going to do the third root. So third root, scroll all the way down. So third root of 70 minus the 6. And then at the bottom, we put a 4. And then to the side, we put a plus 2. And there it is. Look at that perfect match. 3 is equal to 3 according to Desmos. So then, yes, 70 is my answer. Not the 3 that we found here, but the 70. Now, the last two problems. Remember the honors test, a little bit different. Here's what we were practicing in the last class. We're talking about domain. Now, when we talk about domain, we're always asking ourselves, we're going left to right. So what is the point furthest to the left, or the x value furthest to the left? It would be -4. As I go to the right side, what is the very last point to the right? Well, that would be the number 3. And if that's the case, then my domain goes from -4 to +3. But at the -4, there was a closed circle, so we use a bracket. And to the 3, we do have an open circle, so we would use a parentheses. And that would be our domain. Remember, when you're doing domain and range with interval notation, we don't need inequalities anymore. Now the range, we go from the bottom to the top. So that's how we do range. So the first question is, what's the lowest this graph gets? Well, -2. That's the lowest the graph gets. And as I go up, the graph exists, the graph exists. This is the biggest value for our y value here. So my graph exists between -2 and all the way to the top, the number 5. So from -2 to 5. Now at the -2, we do have an open circle there. So I do need a parentheses. And when I get to the 5, there is contact there because it's closed circle. So we bring in a bracket. Again, domain and range and interval notation, we don't need to bring in the letters x or y, but we do have to remember the order in which to write the numbers, smallest to biggest. All right, finally, last problem here. Now, when I'm looking at this one, yes, it's a quadratic, but I have to look at this. They end with arrows. So that means they're going to go on forever. Now, when we say forever, notice it's going up forever, but it's also going to the right forever in this case. So it's up forever, and it's also going to the right side forever. So these are things we have to keep in mind, because that means if it's going up forever, we're dealing with infinity. If it's going to the right forever, well, we're dealing with infinity over here on the x-axis. And then when I look on this side, well, it's also going up forever. So I already have that positive infinity. I don't need to write that again. But it's also going to the left forever. Arrows always go forever, we'll say, in 2 directions. So then if it's going to the left forever, the negative infinity is going to show up. So with that said, when it comes to domain, is there an actual point that you can say that that's the last point on the graph? No, it goes on forever to the left. So negative infinity shows up. And of course, infinity always carries a parentheses. I also can't say, oh, this is the number that the last number for the x's. It's an arrow. It keeps going forever and ever to the right, which is why we bring in positive infinity, and infinity always carries a parentheses as well. So range. Now, when I do range, remember, domain was left to right. Range is bottom to top. So what's the lowest y value this gets to? -4. Look at that. It hits right at -4. So that's the lowest. What's the highest this graph goes? See, it never stops moving. It goes up forever. So positive infinity shows up. But when you write to range, remember, you start from the bottom, so -4, and then you work your way up. Well, we already said it's infinity. Infinity always carries a parentheses. But the -4, now if you look, it does make contact. They don't have to draw a dark circle to say it's closed. If you make contact with the graph, then it's an automatic closed circle. So we use the bracket. If they wanted that to be an open circle, they would have exaggerated that open circle for you so you can see it. All right. So with that said, now we are officially done with the review, especially with the honors portion. So again, continue to do the you-dos and of course, work on the homework. Have a good day.